There we go. Get in back here. It's all done. Okay. All right, so if you're finishing things up, I don't mean to rush you. I just want to give you permission to send it towards the middle if you're ready. If not, I'm looking for symbols, not words. Hopefully that's what you're doing. For most of you, it's actually all of them. Is that yours? Yeah, no. This is your pen? No. Okay. Well, be sure. I don't know if that's yeah. This is the extra. Very nice. There's quite a pile of extras. Weird. Glad people were absent. I only have one. Does anyone else have extras? What if the printer ran out of paper? Usually they make extras. Oh, here they are. Here's one. Wow. All right, try to wrap things up here in just a minute. And then, oh, you have extras? Or no? And, we'll move on in just a minute. Very good. Good job. You get points for knowing where the countries are? If you know where Canada is? It's fascinating. All right. Oh, why? It's not me. I didn't see you. Sorry, I'll mark you a present. I'll do that. So try to finish up. I'm just going to fix my attendance here. Done. Okay, done. All right, hopefully you're coming down the home stretch. Those who are savoring the experience, you're all set. Excellent, good job. Best couple here. See how we're doing. You got it. Good job. Well done. Don't second guess yourself. Oh, you got a big one there. Yeah, good job. Don't second guess yourself. Good job. Okay, I think I got them all. Make sure. See if I can get these to staple. Good. Okay, so let's go ahead and see how we did. Okay, so first of all, the claim, easy. You're looking for whatever is the statement up here. So let's see, cyclist states, usually it says something like this, that they ride bicycles less than 45%, 0.45. So there's my claim, P, proportion. It's not an average, it's a proportion. So proportion, but for these things, you're always going to either have a proportion or an average. So if you put average here, you're, at least in the ballpark, I guess. But this is a proportion, less than 0.45, opposite, and then you just have to sort these out. If you left your, the greater than, for example, here, I'll just do it here. If you did this, I am happy. That's totally fine, just like Newton does. I don't know, I like to have the whole thing there. It doesn't matter to me though. So then because of this is left-tailed, and then which of these, if we're testing this at 0.01, what that means is that there's a 1% chance that that we'll get it wrong and think that it's not by chance, but it really is. So there's a 1% chance that the proportion, that we think the proportion is less than 0.45, but in fact it's equal to, well, or greater than 0.45. So that's that one. Let's move on. Second one was also proportion. I should have had a mean on there, but oh well, maybe next time. We're going to have a couple more of these before the test, but I just want to get you in the sort of in the get you doing this right, so that that when you get to the test, you'll just be like, oh, it's super easy. You'll be done early. But anyway, Frank here, he thinks that this is greater than 50%. So that's greater than 0.5. So there's your claim. Yeah, he believes. Anytime you have something like that, that's the claim. Opposite, of course. And then I've got these things sorted out. That's supposed to be a comma, not a 1 down there. Maybe I can fix this 5 as well. So 5, comma. That's better. And you're going to want to have the actual symbol there, whether it's mu or p. This thing's right-tailed because of the alternative hypothesis. And if you did your homework, you probably did several of these, and you're like, oh, wait a minute. Whenever this test statistic, whatever that is, you don't even know how to compute it yet. We'll deal with that soon. Wednesday we'll deal with computing these things. Anyway. When that thing is in the rejection region, you reject the null hypothesis. If it's over here, you accept the null or fail to reject the null hypothesis. And there it is. We didn't have a conclusion here, but we'll be dealing with conclusions quite a bit. I have a template for you. Okay, onward. So what are we doing today? Do we want to do statistics you can use yet? No, let's do this. We'll have that at the ready, but we're going to do this first. So, just a reminder, Wednesday is Excel day, possibly Friday as well, but for sure Wednesday. Depends on how far we get on Wednesday. There's a lot of stuff to get through on Wednesday with our hypothesis tests. As you can imagine, we have to set up the formulas, and they are a little bit chunkier than the ones that we used for the confidence intervals. So this one is going to take a little bit more time, a little bit more patience. Make sure you bring your laptop. If you want to bring a fake laptop, I think you might be able to get by on this day with your iPad or you can tell Briar he might be okay with his Chromebook if you see him. But there it is. Okay, so today what are we doing? We are dealing with, let's see, scroll. It's here somewhere. Wow, so much junk here. There it is. We're at the very end, basically. So there's an A there. I don't know. Oh, H sub A. So we've already dealt with this stuff. And the left, right, 2. You're getting sick of this, aren't you? So if you're getting sick of it, it means that you know what's going on. Alpha we've kind of talked about, but hopefully it'll sink in what that means in a bit. This business is basically the distribution you use is dependent upon what type of test you have. If you have test for means, you're going to use what the t distribution, it's sometimes called a t-test. You might have heard that lingo in your psychology classes or what have you. And then if you're using the proportions, it's a z-test. So that'll be built into the thing we do on Excel. So you don't really have to worry about that. Mainly here, you just have to know which of the tabs, and it'll be obvious. If you have means, click on the one that says means. If you have proportions, click on the one that says proportions once we get it set up. So you compute the test statistic and p-value. That we're going to do Wednesday, possibly Friday. So that's going to be good. So today we're going to be focusing on these two things, making the decision, which we sort of dealt with on Friday, and summarizing the results in a complete sentence. And the one thing that I want to sort of point out before we do this, that the thing that I want to really deal with is, are we right? Are we wrong? One of the things that bothers me about people speaking about statistics, and it's not just students. This is smart people, like journalists or even PhDs will use this sort of language where they'll say that statistics proves that you fill in the blank there. No. Statistics doesn't prove anything. Statistics is a tool to gather evidence. Think about going to trial for murder, and you're trying to prove, in quotes, that someone killed whoever it was. But you're never going to prove it. You're just going to provide evidence. And that evidence might point towards this person being guilty or point towards this person being innocent. And hopefully the preponderance of the evidence will show one way or the other. It's the same way in statistics. We get our hypotheses. Those hypotheses, you can think of them as, are you guilty or are you innocent? So the alternative hypothesis, that's sort of like you're guilty. Not guilt, like in terms of my deck of cards, I'm guilty of cheating. Like there's something funny going on and it's not just dumb luck. So that would be the alternative hypothesis. The null hypothesis is innocent. I'm innocent of doing any weird stuff with the cards. So we're looking for a preponderance of the evidence. We never prove one way or the other because you could still get lucky even if there's a 1 in 100 chance. I could, like, you pick a number between 1 and 100 and I say it's 65 and you're like, oh, it was. I just got lucky. I have no idea what you were thinking, okay? So that it could happen though. There's a 1 in 100 chance that it happens. So the thing that we need to focus on, I guess, or what I'm trying to focus on today is what happens, like, or what could go wrong. So what could go wrong when you're doing a hypothesis test? So I've got a little grid here to illustrate what would go wrong. Let's see, let's skip that and let's go right on to this because this is fun. So I've got this little chart here. And so when you get down to that decision you're going to make about the null hypothesis. And the null hypothesis, you're going to say, do I reject the null hypothesis or do I fail to reject the null hypothesis? So I need a null hypothesis. So here is my null hypothesis. I'm going to inspect a parachute, and the null hypothesis is that the chute will fail. So in other words, I'd like some evidence. I'd like to find some evidence that would show me that this is not true. So my alternative hypothesis is the parachute will not fail. So you can imagine that if you're trying to pack your parachute and you want to know, will this parachute fail or will it keep me from dying? You would want the probability to be pretty low. That is the cutoff. Like when you're not going to jump out of the plane if there's like a 5% chance that the thing is going to fail, because that's what that p-value is. The p-value is the probability that this is true, despite the fact that you think this is true. So anyway, if there's a 5%, I don't think I'd jump out of the plane. So this gets to the whole business of alpha level. Where do you set your alpha level? You're going to set it as low as you need to be confident that you don't make a bad mistake. And in this case, the bad mistake you might make is jumping out of the plane, thinking the parachute will not fail, when actually it will fail. So you'd want that probability to be pretty darn low, like 1 in a million. I don't know if it could get that low, but there's always a chance that something's going to go wrong, so you can't be 100% sure. So when we're testing drugs, for example, we might decide that the benefit of this drug is so great that we're going to set like usually the hypotheses for drug tests are the null hypothesis is that the drug doesn't work. The alternative is the drug does work. So if the benefits for this drug are so great that we don't care about, making a mistake, like the opposite mistake, we might make alpha really big, 10% maybe. We're okay with a 10% chance. If, on the other hand, this drug has horrible side effects, then we might want to be very sure that the drug is going to help people before we give it to them. So we would make the alpha lower. So the alpha level is dependent upon what you're studying. For our purposes, alpha is going to usually be 5% or 1%. It'll tell you, though. You don't have to make that decision. So anyway, let's get back to our parachute thing. So here's our parachutist. Look at that. Happy, happy, happy. So you have 4 things that could happen. You could reject the null hypothesis. That is, I don't think this is true. I think the parachute will not fail. I'm going to jump. But unfortunately, it was true. Well, that's disaster, isn't it? That would be one of the mistakes we could make. That's one of the 2 mistakes. Oops, I guess those are the correct decisions. So if you think that the parachute will not fail because you've rejected the null hypothesis, and in fact, the parachute does not fail, then you made the correct decision. There's another way you could be correct, and that is if you don't reject the null hypothesis. So you believe the null hypothesis. So what happens then? You have to repack the chute. You might throw it away and get another parachute, whatever it takes. In that case, you've also made the correct decision. If the parachute would have failed, how do we know? I don't know that we can. You're with a parachute. I've never jumped out of a plane, but I can't imagine that you can know for sure whether a parachute will fail or not. Maybe if you're like, well, look, that thing is hooked up wrong, so definitely, I don't know. I'm not. I've never done this. Okay, so those are the correct decisions. Here are the things that are wrong. So this sort of a mistake, this type of mistake is one that you really want to avoid if you're jumping out of a plane. So you would want to try to minimize the chances of making that mistake. So that mistake is called a type 1 error. And then the other one, the other mistake, so this is the mistake of saying, I think the parachute's not going to fail. I'm jumping, and it fails. That's tragedy. And then the other type of error is when you don't reject the null. You say, I don't trust this parachute. I'm going to get a new one or whatever. And it wouldn't have failed. It would have been fine. That's not that bad of a mistake to make. If you're going to make one of these 2 mistakes, I think I'd err on the side of caution when jumping out of an airplane. So anyway, you really don't want to reject. This is the one you want to avoid. So it turns out that when you're computing your p-value and all that, you're always focused on this error right here. You see, alpha is the probability of making that kind of a mistake. So that's why I've been focusing on alpha, like this probability. Now you might think that the opposite, maybe if there's a 5% chance of making this mistake, there's a 95% chance. No, it doesn't work that way. That this mistake also has a probability, but that probability is harder to compute. And so we never compute this probability, although we always talk about it, at least when statisticians talk about it, we don't really. But that one, to make this mistake, that's called beta. The probability of making this mistake is beta. Interesting thing about these 2 probabilities is that if you make this probability really low, this probability actually gets bigger. I mean, it kind of makes sense that if I'm going to reject my parachute, if I make this low, it means I'm going to reject my parachute more frequently. Well, I'm going to be rejecting some perfectly good parachutes in that case. And the opposite is true also. If I want to say, I'm going to live on the edge, YOLO, right? Then you're going to make this small so that it's unlikely that you reject a perfectly good parachute. But in that case, you increase the chances that you accidentally jump out of the plane with a bad parachute. So we need to sort these out. There are these sorts, this sort of a diagram. Just that you don't have to copy this down, but this isn't exactly what this looks like. but you'll notice that when alpha, which one's alpha? This one? That if I make alpha really low, put it down here, then beta gets really big, and vice versa. So it's something like this. You have to decide what kind of mistake are you going to make. So here are the types of questions that you're going to see on your homework. So take a look at this. We have, I want to determine the type 1 error if the null hypothesis is that 65% of college students will graduate with debt. Okay, so when I approach a problem like this, you can do it however you want, but here's what I would do, is I would actually write this down, is that P is equal to 0.65, and the alternative hypothesis is that P is not equal to 0.65. There we go. Let's erase that because I don't like the way it looks. Try again. 6.5. Then I have to remember what is a type 1 error. Notice I'm not even going to read this stuff yet. A type 1 error is rejecting a true null hypothesis. Let me go back to the 2 slides that we just got over. We'll go back to this one, don't worry. So this previous one, or the two ago. So whenever you, let's see, oh yeah, that really doesn't say it in words. Here, let me write it down. Reject a true null hypothesis. So type 1 error is when the null hypothesis is true, but we reject it anyway. So back here, so this is type 1. Type 1. So in terms of the parachute, type 1, we're rejecting the null hypothesis, but the null hypothesis is true. So we say, I don't believe that this parachute will fail, and it does. So that's type 1 error. So let's see if we can write this down. And see, I still am not going to read this. I won't write it down. I don't have room, but I will speak it. So let's see. I reject that up there, the null hypothesis. So I reject this. Give me a sec. This, I think, is not true. I reject it. Well, what does that mean? It means that I think that the percentage is not 65%, but it turns out it really is 65%. So let's see. Can I pick that out of the bunch here? Conclude that more than 65% will graduate with debt when in fact 65. That sounds pretty reasonable. Oh, I never even saw the claim. Oh, darn. I have the wrong, sorry. I have the wrong alternative, don't I? This should be greater than. Sorry about that. And so I was trying to avoid reading as much as I could. That's basically what I do in life, but it's not a good policy, is it? So yeah, so if you read this, the alternative is greater than. So, oh look, this is actually it. If I don't believe the null hypothesis, I think it's false. That means I believe the alternative. So I think that more than 65% of college students will graduate with debt, when in fact only 65% will graduate. Only. I know, that sounds terrible. So that's the correct one. So whoops, I'll fill in that bubble, I guess. But you'll click on your Newton. So that's the sort of thing that you can expect on your Newton. Let's see, before we do this, let us go to, let's switch over to this. This is exciting. Uh-oh. Yeah, statistics you can use. Here we are. So next edition, this is the daylight savings time edition. So there are numerous papers. You don't have to look far to find some papers that describe statistical evidence for the fact that daylight savings time kills people. So, for example, here's a couple here. This is from 2020. Let's see, daylight savings time and traffic accident risk. It turns out that traffic accidents are more likely to happen the week after daylight savings time changes, both in the fall and the spring, than in other weeks. So I think what they actually did was they compared the week before with the week after number of motor vehicle accidents. That's what this is. And it turns out that there was a significant increased fatal MVA risk. So there you go. People are being killed by daylight savings time. Let's see, here's another study. And by the way, this is fall and spring, both fall and spring, because in this, you might think, well, why would the fall be bad? We get an extra hour of sleep. Sure you do, except for those workers who have this schedule that forces them to work late, and then it's even later, and now they're super sleepy, so they end up killing people on the way home. So anyway, here's another one, another paper, daylight savings time. This is in hospitals. So patient-related, safety-related incidents following the transition, once again comparing before and after, the week before and the week after. And it turns out, and this is over the course of several years, when was this published? This is published, I don't see, 2021. So also pretty recent paper. So, and look, they have confidence intervals and p-values. Oh, it's so beautiful, isn't it? But anyway, basically what they found is that there were these so-called patient safety-related incidents in hospitals that increased both in the fall and the spring after the time change when you compared the 7 days prior and the 7 days after the daylight savings time change. What can we do about this? Well, sadly, probably nothing. But I've developed a little thing here. A few years ago, I started my own campaign. Well, it didn't go very far, to be honest. This Don't Fall Back. And I thought, well, we can do this. Have some T-shirts. This could be a really, cool thing to be wearing around. Maybe caps and bottles, and maybe even masks. I did this during the pandemic, the years after the pandemic. And then I thought we had won, but I was wrong. So back in, when was this? This is 2022, Marco Rubio in the spring. What a guy. I mean, I'll vote for anyone who says they'll get rid of the time change. I don't care what his politics are. But he pushed through using he was a little sneaky about it, but he got the Senate to pass a measure called the Sunshine Protection Act that would abolish the time change. And I was like, yes, we've won. And yeah, nothing has happened since then. And I even said, you got to contact your Congress. They didn't get through the House of Representatives because people are stupid, apparently. But I love this quote. We don't have to keep doing this stupidity anymore. What a guy. And why would we enshrine this in our laws and keep doing it for so long is beyond me. Amen, brother. So I suggested that students contact their congressperson. I don't think that it'll ever, I think this is still pending. So you could contact your congressperson if you want. Please vote yes for the Sunshine Protection Act. Get it off the back burner or wherever it is. Because changing our clocks twice a year is not only disruptive, it increases deaths on our roads and reduces worker productivity. It's just a fact that we can prove in statistics. Well, proof, we have lots of evidence for. Okay, sorry, I'm done. I'll get off of that soapbox. Let's get back to reality here. Okay, what do we have here? Okay, let's just state the type 1 and type 2 errors for each of these claims in terms of the appropriate parameter. So I suppose that we need to write down the claim and the null and alternative hypothesis. I don't have the room here, so I'm going to move this to Notability. If you give me a minute. So give me a minute, and then you're going to practice. I'll let you do this, and you'll tell me the answers. So I haven't had the interactive. Just a sec. There we go. Paste this baby in there. Very nice. Okay, so A, B, and C, just 3 of them. This won't take too long. Oh, yeah, we got plenty of time. Okay, so go ahead and, first things first. Let's just copy this and paste it again because we're going to need the room. There we go. Okay, so let's just do A up here. So ignore B and C. In fact, I'll get rid of B and C. So we need the claim, opposite of the claim, null and alternative hypotheses, and then we need the type 1 and type 2 errors sort of stated in sort of semi-basic language. I don't know. I'm just going to crop this down a bit so we only focus on what we care about. Oh, there it is. All right, so I'll get this set up. Claim, opposite, null hypothesis, alternative hypothesis, and type 1. Here we don't need much room. We think really think is true. Almost done. Oh no, I didn't mean to do that. What do I undo? Undo. There. Just a minute. I have to be more precise apparently. That's better. Okay, there, I got it all set up now, finally. Okay, find my random people. I know this is your favorite part. Random. Gabrielle, what is the null, or the claim? The claim. Okay, let me write this down. Let me change colors. Very nice. Mu is equal to 2.3. Very nice. All right, Blair, what's the opposite of that claim? That's perfect. Mu is not equal to 2.3. Now we just need to sort out which of those is the null hypothesis and which is the alternative. And Evan knows which one of those is the null hypothesis, don't you? So that's the one that you say is the alternative, you said? I think I misheard. So which one did you say was the alternative? Yeah. Okay, I was trying to help you out there. So anyway, yeah, you had them backwards, but that's good to make the mistake now. So yeah, the alternative is the one. So the null hypothesis is the no difference. No difference. No difference means equal to. So anytime the equal to symbol shows up, whether it be in like a greater than or equal to, or less than or equal to, or just equals, that's always going to be the null hypothesis. And then the alternative is the other one, not equal to. All right, very good. Now let's deal with these type 1, type 2 errors. So you're going to believe one of these when the other one is really true. Calvin, what do you think? What's the type 1 error?
Rejecting the null hypothesis.
When it's really true. Yeah. Okay, so when really this is true. Okay, so what do you think? Remember, you're making a mistake.
Yeah.
So
that it's not true. That's not,
yeah, that this is not equal to. Okay, so you reject a true null hypothesis. So you believe this when really this is true. So that's the idea for a type 1 error. Type 2 error is the opposite. Just switch them up. Let's see how you do. Kylie, what do you think? What is the type 2 error? So that's what you think, and what's really true? That's right, because we've made a mistake. So those are the two types of mistakes that we hope to avoid. And I don't know if one of them is more disastrous than the other, but let's see. I will set up the next one. Let's see. I think I'm just going to copy this whole thing. There we go. This is going to become a problem, I think. Let's see what happens. Yeah, the whole thing showed up down here. Let's see. Can I get rid of this? I can. Oh, I could just do this. That's nice. Okay, give me a sec. See if I can move just that. Apparently I can't. Okay, I'm doing the best I can with the technology thing. Okay, so we have at least 40%. I'm going to erase the stuff that we don't need for this. So all the purple is going to go away. But go ahead and see if you can set up the null and alternative hypotheses for this. And then we will figure out what the errors are. Okay, finally, got it all done. All right, let's see where we are. Who's this? You've already done something. Marlon, what's the claim? Was that? So what symbol are we using? So did you say P? P? Because it's a proportion. So is this at least? So at least 40%. So what symbol do I use for the P after the P? So at least would be stuff that's at least, meaning bigger than or equal to, right? Okay, very good. So P is greater than or equal to, and you said 40%, so 0.4, is that all right? Okay, good. So the P is at least. So this is going back to this, I mean, English, terrible. I was actually thinking about this. I was biking yesterday, and I realized I have complaints about French because I'm trying to learn French. Yeah, English is worse, way worse. Like, think about the way we put an S at the end of verbs when it's a singular. Like, I don't know. It's crazy. Anyway, getting back to this. Yeah, English is terrible. So trying to translate to math. Math is the most precise language. But let's go ahead and, now that we've got that, I think we can do the rest pretty simply. So let's go ahead and do this. Mason, what is the opposite of that? Yeah, P is less than. Yeah, and this is, by the way, this is just, you have to dig deep, don't you, to get this at least for this. It's something you learned in 7th grade, probably, back in algebra or pre-algebra. You learned about words like that, meaning this. And it's something, if you haven't used it, yeah. So hopefully practicing it some, you'll get used to this and you won't get it wrong when we get to the test. Okay, next. All right, Carter, which of those is the null hypothesis? Perfect, 40%. And then this is going to be less than because it's the other one. All right, almost done. Noah, what is a type 1 error?
That 40% is greater than P.
Oh, you think that this. Okay, the way you said that was a little backwards, but it's still correct. So that's what you think. You think that P is less than 40% when really the null hypothesis is true, right? P is greater than or equal to. Very nice. Oh yeah, we got 10 minutes, so we're going to be okay. And then the last one is this, whoops, where'd it go? Come on. AJ, what about a type 2 error? What does that look like here? All right, very nice, very nice. I had one more. Let's whip through this really quickly, and that's this last one right there. So the average, I'll bet we can do this without having all the notes. Maybe we can just talk through it. So let's see. So here we are. So see if you can get there. I'll just put null hypothesis and alternative hypothesis here, and then type 1 and type 2. All right, Bailey, what's the, what's the claim?
The claim would be that the average is greater than or equal to 64,000.
All right, very good. So at least, that word at least, or that phrase again, greater than or equal to, so mu is greater than or equal to 64K. Very nice. All right, and then the opposite, of course, is less than. All right, let's find another person. Lily, what do you think of is the null hypothesis in this one? Yeah, so once you see that equal to, you say, oh, that's the important stuff. And you could write it like this, or you can leave off. In fact, you know Newton. Newton is going to leave off the greater than part and just say equals, which is totally fine. And then, of course, the alternative is the opposite. Now let's see if we remember the, what? What's wrong? Did I do it wrong? No? Okay, sorry. Okay, so Haley, which one's the type 1 error?
Mu is greater than or equal to 64,000.
So that's what's true. And what do we think? Yeah, so that's it. So we think that mu is less than 64K when really mu is greater than or equal to 64K. And then the type 2 error is the opposite. We think that mu is greater than or equal to 64K when really It's less than 64K. All right, I wanted to check on something here. So there's our little 3. Here's the preview of the homework. I just want to make sure that we're good with everything, because I sometimes mess up and don't go over something, but you're good with this. You can figure it out, but let's just make sure. So this is pretty straightforward. It talks about the null hypothesis, the alternative hypothesis, and you're supposed to sort out the type 1 and type 2 error, and it even gives you these choices down here. You'll get a few of these wrong, mainly because these are written in plain English, which isn't all that plain. So do your best. If you get a few wrong, you know the drill. It's not that big of a deal. Okay, let's switch to the next one. Let's see, that's the one we're on? Okay, so here's this, p-value. Yes, okay. So we've already gone over this sort of, but I wanted to just remind you of how this works. So here we're given a p-value of 0.973. That's the probability of the null hypothesis being right, I guess. So remember that this is like the probability that I actually did something cool with my magic trick. And that's almost 100%. Wait, it's the probability that I just got lucky. Sorry. Probability I just got lucky. So if this is bigger than 5%, so here I'll just write this down just so that we can remember. Give me a sec. So here, so you have the critical value, which we had some of that on your homework for today. And then the p-value approach is really similar. And here's the rule. If the p-value is less than alpha, then you reject the null hypothesis. If the p-value is big, I think we talked about this before, but I wanted to make sure. That's why I wanted to do this. So if the p-value is less than alpha, you reject the null hypothesis. So the critical value, that's the whole business of, are you in the rejection region? You know, there's something here, and then if the dot is over there, that was that deal. So let's just take a look at that. In this context, it says, let's see, that this is pretty darn big. It's way bigger than 5%. And so I'm not going to reject the null hypothesis. So I failed to reject the null hypothesis, and the reason is that the p-value is way bigger, way bigger. Oh, wrong one. There it is. So there it is. So we can submit that and be happy. You'll have a bunch like that that you're trying to sort through. And then one more to look at just to be sure that we got it all. And this is the same thing, but in terms of hypothesis test for means. So this will be the same idea. So you've got, you know, they'll give you the information here, and they just tell you that the p-value happens to be less than 0.005. And so because the p-value is small, less than alpha, I think the alpha level, what's the alpha level? It doesn't say. But anyway, the p-value is really small. And so, it says the significance level. You're going to reject the null hypothesis. So when you have a small p-value, it means that it's probably not due to chance. Probably not getting lucky with my guesses. There's probably something else going on. So p-value being small, reject the null hypothesis. It's kind of the opposite with the critical value. I like to focus on the p-value approach, and in fact, that's what we're going to build into the spreadsheets on Wednesday. So did I mention Computers Wednesday? Okay, good. Wednesday computers, that's it. Stick around if you have complaints or questions. I'm going to turn off the recording just in case.